Alright, this is the second video to finish out the last part of these notes. This one will be kind of quick. We just finished talking about the inscribed angles and when they have the same intercepted arc, that the angles are congruent. Now we're going to talk about the right triangle rule. So basically, if a right triangle is inscribed in a circle, then the hypotenuse is the diameter. That's important. The hypotenuse has to be the diameter of the circle. The converse of that is if one side is an inscribed triangle, if it is the diameter, then the triangle has to be a right triangle. What that means is that this diameter right here, AC, is going to be the hypotenuse of a right triangle. The right angle would be B. Now, we know that when you have a right triangle, we've done this before, when you have a right triangle, the hypotenuse is always opposite the right angle. That's always your hypotenuse. We also know that when you have a right triangle, if you know which one is the hypotenuse, the one opposite is the right angle. That's what we're looking at here. Also, think about, it makes sense with what we just talked about with inscribed angles, that if you have a diameter and that's part of a triangle like this, this measurement of this angle is 180 degrees because it's half of a circle. Well, this angle is inscribed. This inscribed angle has that as the intercepted arc. What we just talked about is that this measurement of this angle would be 1/2 of that arc, which means that it's 90 degrees. It's 1/2 of that 180 degrees. So a diameter makes a semicircle, which is 180 degrees, and the diameter would be the one that would be across from that 90-degree angle, which is your hypotenuse. So basically what this rule is saying is the diameter is the hypotenuse of an inscribed right triangle. Or if you know you have a right triangle, the hypotenuse is going to be the diameter. An inscribed polygon, just like an inscribed angle has its vertex on the circle, an inscribed polygon has all the vertices on the circle as well. That's what makes it inscribed. It touches the circle around the edge. The quadrilateral rule, let me finish this first. AC is the diameter and hypotenuse. And then angle B, that measure, is equal to 90 degrees. That's, again, basically what that rule says, that if you have a right triangle, the hypotenuse is the diameter, the angle opposite is the 90-degree angle. The quadrilateral rule is another rule dealing with polygons, and it basically says that a quadrilateral can be inscribed in a circle if and only if, that's important, its opposite angles are supplementary. If and only if means this goes both ways. So if the opposite angles are supplementary, a quadrilateral is inscribed. If the quadrilateral is inscribed, then the opposite angles are supplementary. Remember that supplementary means that they add to be 180 degrees. So sum is 180 degrees. So basically what this is saying is that the opposite angles E and G are add to be 180 degrees, and opposite angles F and D add to be 180 degrees. So angle E and angle G are supplementary. Angle F and angle D are supplementary. And we can also write that with the measurements. The measurements of angle E plus the measure of angle F equals 180 degrees. The measurement, not F, angle G, that's supposed to be a G. And then measurement of angle F plus the measurement of angle D adds to be 180. That's how we set up equations. We add them together and set them equal to 180. If you think about that, if I think about the fact that the intercepted arc here of F and D This would be the intercepted arc. That's one part of the circle. The other part is the rest of the circle. That would mean that the whole circle is 360, and those angle measures would be half that, which is 180 degrees. So they are supplementary. What we're going to look at in these examples is that we're going to find the value of each variable. In the first one, this BA, that is the diameter. So that means it's the hypotenuse of the right triangle. Across from it would be a right angle. That 2x is a right angle. Angle C is a right angle. So I know that the measurement of an angle is 90 degrees. So the measurement of angle C is 90 degrees. I need to solve for x. So I'm just going to set 2x equal to 90 because that's what the angle is. And then divide by 2. You get x equals 45. That is not the angle measure. The angle measure was 90 degrees. X is 45. For B, this is a quadrilateral, which means that the opposite angles are supplementary. So y and 120 add to be 180. So I'll do y plus 120 equals 180. That's just setting up an equation. We're going to subtract 120 from both sides. And you get y equals 60 degrees. All right, and then for z, we would do the same thing. Z plus 80 equals 180. So then we would subtract that, subtract 80 from both sides. You get z equals 100 degrees. All right, I want you to pause the video and you try part C and D on your own. All right, for C, you should have gotten that 3x was equal to 90. That makes x equal to 30. For D, both of these you would set them up and set them equal to 180. So x plus 85 equals 180. When you subtract, you get that x is 95 degrees. And then for y plus 80 equals 180. When you subtract that, you get y is 100 degrees. Those are your answers there. I'm going to work this part E with you. These are opposite angles, so I can see that I have these two angles opposite each other, which means that they are supplementary. Supplementary angles add to be 180. So when I add these together, I have 3x minus 8 plus 5x plus 2 equals 180. That's the first angle plus the second angle equals 180 degrees. I'm going to solve this multi-step equation. 3x and 5x add together to be 8x. Negative 8 and 6 add together to be negative 6. That equals 180. Add 6 to both sides. You get 8x equals 186. Then divide by 8. You get that x equals, when you divide that in your calculator, 23.25. And that is where we will stop for this set of notes.